pipeline. What are those columns? Our columns are present in, where is that? 0 missing columns. All right. So column names we need to apply. So these column names will be applied with this transformation and the key value is this. Is this part clear? We are appending on transformer. Are we clear? Okay. Next is we will check just the list, whatever I said, right? For C in column remaining, so whatever columns are remaining in here, whatever columns are present here, check that if that is not present in 0 missing columns that we have passed here. If it is present in a part of imputation, don't add it. We have mentioned not in. So this particular thing will only contain columns which are numerical and are not a part of imputation. Okay. Numerical columns and not part of imputation. Done. Now what we are going to do, once we know which are the columns which we need to perform, simple, we will just check if this thing's present. If any of the column present, then what we are going to do, transform dot append, we can directly write it. This one is nothing but your sklearn pipeline. So let's write sklearn pipeline here. Instead of this one, I'm going to write sklearn pipeline and standard scaler. That's all. Clear? Everyone? Instead of writing this whole thing and saving into a variable, I can directly pass this whole thing into the second argument, which I did it in this part. Sir, why do we append? Because we are creating a list of objects of sklearn pipeline, Shiv, and this transformers we will pass to column transformer. Okay, we will pass to column transformer. Okay, yes. Now we also need to add what? We also need to add remaining columns. Where is remaining columns? Yes, remaining columns. We will pass remaining columns here. This column will be applied with sklearn. Okay. These columns will be applied. Okay, I don't think so. These columns, we only need to pass remaining after impute. Okay, only remaining after impute because this is what we selected. Everyone see this code. Is this part clear? It should not be impute scale. Oh, it should not be impute scale. Correct. We can mention, write anything at all. We can write scale all. Scale all. Done. Everyone, is this part clear? If we don't require any imputation, if 0 missing columns are present, then we need to do scaling of. Then we will do scaling of. Guys, if no columns are there to imputation, if no columns are there for imputation, then we will do scaling on. Guys, see this concept, very simple. I will show you what I'm doing. Again, I have written the same code. I have a list where we need to perform imputation. Here we have 1, 2, 3, 4, and 6. And I also have all the numerical columns of my data frame. 1, 2, 3, 4, 5, 6. Which is one of the column present extra in numerical. What is the one column present extra in numerical? 5. 5 is not present in imputation because 5 is the pregnancy one. Okay. So what I'm doing, first of all, I am creating a transformer list, which is going to be empty list, and it should contain object of pipeline, object of sklearn pipeline. Are we clear? Transformer is a list where we will keep on appending object of sklearn pipeline. Then what we are doing, first we are creating a pipeline to do the imputation. Okay, first we are creating a pipeline. What is pipeline? Pipeline is nothing but it's a process. That's all. In a pipeline, we can have two process. In a pipeline, we can have three process. That is what pipeline is. Quality, are we clear? Okay. In this pipeline, we are doing first imputation. We need to do imputation on. We need to do imputation on imputation list. Imputation on imputation list. Now I know this imputation because I know my data set. Can I also do a scaling of 1, 2, 3, 4, and 6 as well? Can I do scaling of 1, 2, 3, 4, and 6 as well? Okay. Now I am doing what? I am doing scaling on imputation list itself. This is my pipeline number 1. I will now use this. I will now append 1 to my list, to my transformer list, which I created above. Yes, this list which I created above. Is this part clear? Okay. Now next thing is, I did the scaling only on imputation list. Do I still have numerical columns left? If yes, which of the columns are left now? Which of the columns are left now which are numerical and was not part of imputation? Everyone? 5. Now what I will do, I will create a second pipeline. Here I will check in a list comprehension. I will write whatever was present in imputation list and whatever we have in numerical. If I will iterate over it, I will check if numerical is not present. If numerical is not present in imputation list. So in numerical, which of the following column which is not present in imputation list, it will return me 5. On this 5, now I will create a pipeline and I will only do scaling. I will only do scaling on column number 5. Are we clear? Everyone? Now, if there is no column for imputation, let's suppose because we are doing it programmatically, if there is no column for imputation, do we need to go and do these 2 steps? No, this is a part when imputation is required. If there are no columns left for imputation, else, can I create this pipeline and instead of scaling of 5, I can do scaling on all numerical columns? All numerical columns because I don't have any of those columns for imputation. Done. This is what we are doing in coding. Same thing. Created a pipeline with imputer and standard scaler. Pipeline number 1. Once we create it, we are appending on transformer. This is part 1. Part 2. We are iterating over the original numerical columns and checking if any of them is already processed before. So this is only going to process pregnancy. Pregnancy, we will do the scaling. This is a separate pipeline which we created and directly appending to the transformer. Here I appended it by creating a separate variable. I can also do it here, but it is a short code, so that's why I'm doing it in a single go. In a else part, what I have to write? In a else part, can I copy everything? And instead of remaining after impute, I can just write remaining columns, all the numerical columns. Remaining is my all numerical columns. Yes. I don't need to change the key because only this part will run or this will run. My task is done. My transformers list is done. This list will contain the key, object, and the columns we need to perform. Then Baiju, instead of passing this transformer, we can pass multiple transformers. We can append multiple impute A, impute B, impute C by passing different columns. Yes, clear? We can create multiple transformers. So guys, let's run it. Once we have the transformer, now what we are going to do, there is one thing which I wanted to show you, one interesting thing. Okay, always new arguments I wanted to show you. Column transformer, we are passing the transformer list here, which contains all the pipeline instructions. And we are saying it as remainder equals to drop. How many of you remember that remainder we were using it before? The previous remainder was passed through, yes or no? The previous remainder was passed through when I used in the previous class. Now I am using a remainder called as drop. When I use a remainder of drop, everyone, when I use a remainder of drop, we are specifying to this column transformer that we are not explicitly including any of the transformers. Okay, let me write it. Okay, let me just write it. Okay. To any columns in our data set. Okay, let me write everything. Let me copy. Remainder drop specifies what should happen, okay, to any column in our data set that were not explicitly included in any of transformers. Okay, we defined. Now see this, what does this mean? Let's suppose in my data frame, I have 1, 2, 3, 4, 5, 6, 7, 8, and 9. We are using 1, 2, 3, and 5, 6 for imputation plus scaling. If there is no imputation, then in the else part, we will use everything for scaling. Yes or no? Yes or no? Which are the columns we are not using? 7, 8, 9. So when we perform remainder equals to drop, when we say remainder is equals to drop and pass the whole transformer object which we created, it will drop 7, 8, 9 because it is not being used in any of the transformers. Are we clear? Are we clear? Now comes remainder is equals to pass through that I talked about in the previous class. It will, even if we don't use 7, 8, 9 in any of the transformers, it will let 7, 8, 9 pass through those pipelines, those transformations. And once the transformation of 1, 2, 3, 4, 5, 6 is done, it is going to concatenate 7, 8, 9 back to the original data frame. It will transform, don't do anything on 7, 8, 9 and append it to the final data frame again. Are we clear? That is what pass-through does. Guys, are we clear? Just a functionality from the method, from the class. That's all. So currently we want to drop anything which we are not using. Okay. This part is done. This is all the pre-processing which we are doing. Now, very simple thing. I want to use, in case of drop, it might lead to data lose. Mantaj, yes. If we are not doing, if we don't know what columns are going to be dropped, we should not use remainder. But currently, we have a pretty good control of what columns we want to use. We are using everything. That's why I'm making it as drop. Okay. Now, Where is that? Okay, I have to import logistic regression. Very simple. Sir, when we have to create job lib, do we create job lib for column transformer? No, we will just create, yes, we will just create job lib of preprocessor. See, I will show you. Okay. Guys, focus on the class. I think you are using media imputation for learning, but we are used. Jonas, what are you talking about? Media imputation. Everyone focus. Logistic regression. Then I'm going to create a model. See this. I'm going to create a model. This is logistic regression. Solver is lib linear. There are multiple solvers. One we are using is lib linear. Iteration. These many number of epochs. Random state is 42. This creates a model. Oh, median for imputation. Yes, guys, I am using median. You guys can improve it. Okay, it's totally up to you. You guys know what are the different methods of imputation. CLF. This is our model. This is our preprocessor. Now we will be using sklearn pipeline to run everything. Okay, we were using this before. Now see how I'm creating the final pipeline to run it. Now again using sklearn, I will create final pipeline. sklearn pipeline. This contains two elements. First element is preprocessor key, preprocessor object. CLF key, which is nothing but this model, and then classification. CLF is classification and the object. Is this part clear, everyone? It has two component preprocessor which we created this whole thing, the transformers. Okay, column transformer is the preprocessor which we added here. Second thing is model. So when we get any data, what we are going to do, we are going to apply processing and then we are going to train the model in a single pipeline. Are we clear? We created a simple pipeline which will, when the data gets into it, it will do the pre-processing, scaling, everything. Then it does the classification training model. Are we done? Are we clear? Created pipeline. Simple. Now, final thing, pipeline dot fit. We are passing X train, Y train. It will do the pre-processing on top of it. Then it will train the model. Okay. So guys, when we do pipeline dot fit is same like what we were doing in fit and transform. Okay. Preprocessor, let me just write. Preprocessor.fit will run on X train. Then we will run preprocessor.transform on X train. First, we learn the training components like fit. Internally, it does the transformation on X train. That's how we got a new X train. We don't do any transformation on Y train. Yes. Is this part clear, everyone? And then we will just write pipeline fitted to data. Done. Model training is done. Guys, are we able to understand, yes or no? Sir, how does the pipeline know not to transform and pre-process Y train? Safe, because we are using sklearn pipeline. We are passing the always, even if you train a model, the first argument goes is, guys, when we train a model, the first argument goes is train. So it will apply the preprocessor on the first one and training using X train and Y train. How many of you can create the simple function with Python also? Guys, how many of you can create similar function like this in Python? Okay. Everyone, you guys can do it. Everyone knows Python. Everything is just going Python. See this. We are passing in normal Go. What we do, we have X train. I will apply first imputation. Do we apply imputation on Y train? Do we apply imputation on Y train? No. Once imputation is done on the same X train, what I'm going to do, I'm going to apply scaling. Once scaling is done, then what I want, I will again import logistic regression, create an object of CLF. What I was doing in the previous classes, CLF dot fit, we were passing X train and Y train. Yes or no? Yes or no? Yes or no? We were passing this Y X train itself. Now this time what I'm doing, I created a pipeline of first imputation plus scaling. This is pipeline number 1. In pipeline number 2, what I did, okay, this is pipeline number 1. Then what I did in pipeline number 2, I created a pipeline of this whole thing as this box. Plus I added what? CLF model. Now this transformation plus the model is a part of pipeline. Are you clear here? Are you clear here? Now in this pipeline, because it is again from sklearn, what I am doing fit on X train and Y train. X train will go to imputation and scaling. Then it is a fit part. Then we need to change this data. We will do the imputation. We will learn the imputation using fit. We will learn the scaling using fit. Once the learning part is done, I told you before, then what we do the transform to apply the actual transformation. So X train will be transformed. Yes, yes, this part is done now. Everyone, this part is done. What is left? Model training. If my X train transformation is done, Y train is as it is. Can I send both of them to do the fit, model fit? My task is over. It is just a systematic way. You guys can do it in one by one. It will be simpler. But my target is not to show you the simple method. My target is to show you different methods. Okay. In the next class, I will show you some. Okay. How many of you remember in the linear regression? In the linear regression, did we created? I don't think so. We use this pipeline in linear regression. Yes. Original one. In the original one, I don't think so. We have used the pipeline. So you guys can also create a model like this, but this is just a different way. I hope everyone is clear. Yes, Smith. Because the first argument is train. If I pass the first argument is Y train, it will sklearn will try to fit the Y train, which is not. Okay. We used column transformer for imputation, but I think we used for model training. Okay. Okay, great. So guys, see, if everything looks very complex to you, I will show you 3 simple steps how to do everything. Everyone focus. We will create. This is very simple way, but pipeline way is what you might see in some of the cases. I am going to write simple imputer, SI. This is small. Then what else we have? We have standard scaler. Okay. This is standard scaler. What else we need? We need logistic regression. CLF. These are the 3 components which we have. And if I show you our linear regression, let's see. Guys, this is our linear regression file. Okay. Where is that? I just wanted to check. Okay. Done. In si.fit, I want to apply fit on X train. Yes. Yes or no? I will get SI. Then what I want on this same SI object, I want to do transform. On X train, it will give me new X train. Done. Similarly, we will do for standard scalar. Now we are doing on every case. I know this might look very simple. This is simple. But now next is in CLF. CLF is the model. We will do fit. Our transformation and everything is done. And we will just pass X train, comma Y train to fit the model. Done. Within 5 lines, we are able to do everything. Clear? This is without pipeline. Is everyone clear? We did the simple imputer on X train. Yes, guys, pipeline is a unique way to do all of this. I just want to show you a different way to do all of this. But everyone knows how to do it? Yes or no? If you want to predict it, how we can predict? Using CLF dot predict. We can just predict on whatever set we want. And we will get the result. Similarly, like this, which we were doing before. This is this one. And then say this, we were always doing fit. And then this is predict. This is alternative simple version, but currently I'm commenting all of this. You guys can refer it, but I want all of you to understand this pipeline. Okay. The more complex way you will learn, the better it is for you as starting phase. Everyone knows this, yes or no? Guys, everyone knows this method, yes or no? I've shown you fit, transform, fit, transform, fit, transform. I've done it before. This is simplest method. If you can create a pipeline, now see this, you have to create an object of SI, you have to create an object of SS, you have to create object of CLF. Now that you have, in future, let's suppose you are doing tens of transformation. Guys, in future, let's suppose on X train, on whole X data, you want to do 10 different transformation. Some have mean, some have different things. Okay. You are doing a different kind of complex. You have A, B, C, D. You have 5 columns. On A, you want to do mean. On A, B, you want to do median. So for this, you will have a different imputation object. Yes or no? For this, you will have a different imputation object. Again, for all of this, you might have different imputation object. Yes or no? So here we have 5 different imputation. You have to, using job lib, you have to save 5 artifacts. But if you create up all of them in a pipeline, all you have to do is save pipeline. So for complex cases, this will always work rather than creating all of them one by one. Are we clear why we are using pipeline? Because I want all of you to be ready for bigger things. This is good. In 99% of tutorial, all you will see is this method. It always works like this. Done. Can I move forward now? I hope everyone is able to understand this pipeline part. Okay. I'm feeling you guys are not really interested in learning today. Or is it getting too overwhelmed? Guys, do you want me to teach always on easy mode? Everyone, do you want me to teach on an easy mode? Easy mode. Correct. Only I can help you current at this stage to help you grind on all of these topics. It's fine. Hardcore teaching is good. Yes, good. Great, guys. This is what I want. Okay, we are done with pipeline.fit. Next thing is, yes, easy is lazy. Next thing is, we are done with fit. Pipeline.fit. Next is, correct. Very simple. We will do the prediction. Let me delete this, and after this we will create the prediction. Pipeline.predict X train, we will get Y train prediction. Okay, this particular step will do what? This particular step will do X train, and then internally it is going to take this input, and internally by default, because it is a logistic regression model, it is going to use CLF. CLF internally is going to apply the output. See this. What is going to happen in the predict part? First, using all X train, we are going to do dot product with, its weights plus bias. Yes, y equals to mx plus c. We will get z. Now we are going to apply what? On all of this z which we got, we are going to apply sigmoid. Guys, when we do predict, currently I'm talking about predict. In predict, we are not going to update any weights and bias. On all the sigmoid, we will get y prediction. Okay. Is this the output which we want? Is this output we want? No, this output will be contains probability 0.1, 0.2, 0.9. The output we want is either 0 or 1. So internally, logistic regression, when we do predict, it applies the threshold like this. 0.5 is the by default threshold which it applies. So here, if the output of sigmoid is we get as probability, we will check if probability is greater than or equals to 0.5, then 1, else 0. And whatever the answer is, that we will call it as y predict. So when we are going to write y predict here, it is going to do all those 3 steps which I mentioned. 0.5 is the by default threshold. Are we clear? Are we clear? Okay. It means 50% probability. We are saying 50 or more, we are saying it as 1, else we are saying it as 0. Okay. So this is for train. I'm also going to do for test, X test. Let's predict it. And I will show you how the output looks like. Print. We don't need print here because we are working with notebook. And let's use it. Yes. Are we getting probability or answer? Baiju, now I'm going to show you. Are we getting probability or the final answer 0 or 1? This is after applying the threshold. This is not a probability. Yes, this is probability on a summarized manner, either 0 or 1. Now, let's suppose I don't want a probability of 0.5 to be as my threshold. Yes, I don't want 0.5 as my probability threshold. Then using this predict, instead of using a method called as predict, we want to use predict probability. It's another method. This method does not apply the threshold logic at the end. This method will not apply this part. It will give you output as this part. Okay. Are we clear? So now that we have the probability, it is totally up to us what logic we want to apply. Let's suppose I want to apply a logic of y test probability. This is my logic. I want to apply a threshold. I want to apply a threshold of greater than 0.9. Let's see whether we have it or not. And once it, I want to convert into an integer as type integer. Let's print it. Only 1, 2, 3 values I'm able to see is having probability greater than 90. Are we clear? So guys, this is a very important interview question. Lot of people thinks that logistic regression is all about 0 and 1. But logistic regression gives you output as probability, which then you use some kind of a threshold logic. Sigmoid, this is output of sigmoid, guys. Sigmoid does not give 0 and 1. Sigmoid gives you output in the range of 0 to 1. Then you apply some threshold, which is a part of post processing. This is not a part of, this particular part is not a part of machine learning. It's a threshold which we apply based on the confidence that we want. I hope everyone is clear now. Guys. And this completes our end-to-end logistic regression implementation. Okay. So if you guys want to do the computation, calculate the accuracy. Now I will show you that. Very simple. Just give me a second. Okay, before accuracy, if you guys want to see side by side, what was the actual value, what is the new value now? Okay, so what I'm going to do, I am going to create a new copy. Does other algorithm use, guys? By default, majority, the simplest algorithm which we have to use is, which one is optimal? OLS is for learning or gradient descent? Yes, logistic regression also uses OLS because it uses linear regression internally. This one is also using OLS. See everyone, Xtrain, I'm creating a copy. Xtrain is nothing but a data frame, right? It is my data frame. This is not a, guys, the main, also one important good thing is in the pipeline, I am passing Xtrain and Y-train. Is it changing my original Xtrain? Is it changing my original Xtrain? No. Internally, it is creating a memory with a different memory of Xtrain, but the original Xtrain remains as it is. In the pipeline itself, in its memory, we have now the transformed Xtrain, which we are using for predict and fit. So if you want to check it, I can show you Xtrain how it looks like. It is not changed in fact. It is the original Xtrain which we use for splitting. Say this. This is the original one, right? We have not changed anything. So Xtrain is a data frame. I'm creating a copy out of it. Then ytrain dot values and y prediction, I am saving into a new data frame. And the probability also. This is, I'm saving it. Now, if you guys want to do the same for test, you can also do for test. And just for visualization. Now see how the output looks like side by side. The actual was 1. The predicted was 0. Probability was 0.19. It means model has not learned well on this feature. But this one is only by 1% we were able to get this one as 1. Yes. I'm talking about train. You can also do the same for test. Anand, when we are talking about 50 GB, we will not be even using pandas. When we have 50 GB of data and others, we'll be using Spark jobs. Spark, PySpark. 50 GB is a lot. 50 GB means our system needs to have more than 50 GB to run OS. Yes or no? If the data is 50 GB, it means that needs to be loaded into the RAM. And something needs to be loaded into the RAM. It means our RAM needs to have that capacity. If we don't have that, then it is not going to even run. So we need a different way to do it. Is this part clear, everyone? Anand, it can be done serially, but again, it's a part of processing, optimization, another part. Is this part clear, guys? Sometimes you guys ask, right? Do it side by side. That's how we do it side by side. And if you guys want to see in which of the cases where actual and predicted were wrong, it means it is not matching, just like here. Do we have some cases? Let's suppose where actual is 0, predicted is 1. We want to see difference between those. Then we can write just a simple Python. Where the test results actual is not matching with test result predicted, give me that data frame. This is all the data frame where actual and predicted is not matching. See this? None of them are matching. This one is 1, this one is 0, this one is 0, 1, this one is 1, 0, this one is 0, 1. All of them have a different. So we have how many rows? Do we have any of this information? Let me check. Apply length. Yes, now we have to use length. Not length, we can use shape. Not sure whether we can use shape directly. It's a data frame. Let's see. Tuple object is not callable. Okay. Something feels wrong. Okay, yes. This is a test set. Okay. This is a test set. But why is it only giving us dot shape as 11? This one is good. Give me a second, okay? I just want to see one thing. Okay, got it. Yes, we have only 21. Guys, this is correct. Guys, shape gives you the correct shape, 21. Okay, and let's suppose you want to see a correct C. Okay, we want to see when the actual output was 0, how many of them were predicted 0? Guys, you guys will tell me what is the function I should use. When the actual output was 0, how many of them were 0 and how many of them were 1? When the actual output was 1, how many of them were 0, how many of them 1? If I have to get something like this, what should I use? What should I use? Precision and recall? Correct, Mantaj. Only Mantaj is correct. Others? See, guys, confusion matrix we can use, but I want to get something like this 0, 1. How many of them 0? Confusion matrix is correct answer indirectly, but Python function I want to use a series. Jonas and Nisha, that is almost correct. Okay. First of all, if I do group by on actual and predicted, actual will only have two values. Yes or no? Predicted will have only two values. So for each combination of actual, we will see the predicted values. Yes or no? But is it giving us counts? It will not give us count. If I apply size at the end, it will give me something like this. When the actual was 0, predicted was 0 40 times, 1 was predicted 10 times. Again, when the actual was 1, predicted 0 was this one. So guys, let's add the wrong terms. 0, 0, 40 is correct. 0 and 1 is not correct. When the actual was 0, predicted was 1. This is 10. 10 plus, let's see, when the actual was 1, predicted was 1, we should not look at this. When the actual was 1, predicted was 0, we have 11 cases. 10 plus 11, 21. Is it matching with the shape of the test set where when the cases were not matching? 21? Yes. So guys, Python, you can do whatever you want. Okay. So this part is done. And now let's start doing some evaluation. Simple. Everyone knows this evaluation. I will talk about ROC curve. But for now, we will just focus on accuracy, precision, recall, F1, classification report is also something from sklearn. I will show you how to use it. Okay. Once we imported everything, now it's just time to pass the values. Okay. I'm creating a function which will calculate all of this and provide me a dictionary, just like I was doing before. Accuracy, precision, recall, F1, confusion matrix, and classification report. Classification report accepts actual versus prediction, output dictionary is true, and other things are same as it is. It accepts actual prediction, actual prediction, actual prediction, and sometimes when the value is 0, that's why we are saying division 0 division should be 0. Okay, we don't want infinity, we don't want any error, that's why we are giving it as 0. Anything divided by 0 will becomes infinite times, right? But we want them to be division, we want those values to be 0. Guys, if we divide any number by 0, the actual mathematical answer is not 0. The actual mathematical answer is infinity. We cannot just divide all the way till infinity. So we go with 0. It is not divisible. So that's what I am saying. If you get any 0 division error, just use 0. Okay. Guys, is this part clear? This function is just using all of this metric in a dictionary. That's all. Is this part clear, everyone? Yes or no? Just look at it. I'm giving you 1 minute. Clear? Great. Now, just compute matrix. I am calling this function and passing y-train prediction, which I predicted before. Okay. And this is going to be matrix train because this is for train. Now, what I'm going to do, I'm going to iterate because it's a dictionary. I'm going to iterate over all the components and just print one by one. That's what I'm going to do. Okay. This one is going nothing but it is a dictionary. If you want to see this dictionary, I will show you this dictionary. It did. Let's run it. What is going on? Y probability. Where is that Y? Guys, is something wrong here? Can you please check? Oh, one additional function was there. We don't require that. See this? Now let's print it. It's nothing but dictionary, accuracy, precision. Now this does not look good. Everything is cluttered here. I want to iterate over one by one and print it. So what I'm going to do, just iterate over it in a for loop. That's all. Okay. So I will print the k comma v value if it is not a classification report and confusion metric. Then I will print it. Okay. So here we have everything except confusion matrix and classification report. Accuracy we are getting over training set is 78. Precision is 73. Recall is 57. F1 is 64 scores. Everyone know how to read all of this? Yes or no? Yes or no? Same thing I will do for test. Now everything included in a single cell, not two cell. We don't require two cell. This one is done. Now let me run test. Again, I'm passing something here. See this? Is the accuracy closer? But I can see there is a difference. Okay. Recall is also closer. And this is 6170. I think there is a big hit on precision, but recall is almost good. F1 is showing you a little difference, but we know the answer because there is not enough data. We don't have a lot of data to learn. Test set might be a different set. Yes or no? That's why data analysis is important. Once we improve more data, we can improve a lot of things by using a different algorithm, by using different validation set, which I will talk about later, but we can improve it. But this is the current one. It is not too bad. Yes. Can we say the model has learned something at least? Correct. Now let's run the classification report, okay, which I showed you. Classification report is one of the output, right? How to create model with good accuracy. Nishal will talk about it later. Now pd.data frame, I am passing matrix of train. This is matrix of train. Inside this dictionary, we have a key called as classification report. So I am passing matrix of train of classification report to pd.data frame to create a data frame. Okay, to create a data frame, and I'm printing this report. See this report? It gives you when the value was 0, what was the precision recall F1 score. This is about 0. Separately for 1. Separately for accuracy we have. See, accuracy we have a single number. Accuracy, what is the accuracy and precision? So because it does not make sense, all of the value are same. Yes, are you able to read this? There is nothing like accuracy and precision. So accuracy row is all same value. Same we have macro average, weighted average. These are just different components. Don't worry about it. But it gives you different report. Okay. Same report you can do for test set if you want. It will give you separately for 0 and 1. And if you want to see confusion metric, this is what confusion matrix looks like. You can again read through. I'm passing CM train. Okay, CM train I'm extracted from train confusion matrix, which we calculated, and I'm just plotting it. You guys all know how to draw confusion matrix. Yes. Shiv, don't worry about it. That macro average, forget about it. Not relevant. There are a lot of things which we can. What guys? Matrix should always be as simple as possible. There are hundreds of different metrics which you can use, but if understanding those is very hard, don't even consider it. As I always focus, your understanding of data should be as simple as you should be able to tell to business. Okay. Precision and recall is also again hard. Average is accuracy is good for them, but precision and recall is again hard. So you need a way to always tell them these stories. Okay. So don't focus on too much. Okay, everyone, say this. When the actual was 0, model predicted 0, 410 times. Actual was positive, model predicted positive 138. So these two are correct cases, model identified correctly. These are incorrect cases. This is what we define it as precision and recall. Yes, correct. This is on training set. Now for the test set, we can also pass the same thing, but just a different value here. We will be passing matrix test confusion matrix. Everything else is same as it is. Now see this 11 and 10, 40 and 16. Same kind of a pattern, but because the test set is small, we are able to see small set. All right. Now let's save the model. How can we improve, guys? We cannot always improve everything. I will give you some of the things you can try different iterations. Okay, let's see if we can get this improved by a okay, you guys can try it. Okay, yes, later you guys can try do a different iteration, try with a different threshold. That is what I will talk about. Just wait. Maybe we are not too confident on the probability. Maybe try with a lower threshold. Maybe you will get everything, because currently we are using 0.5, right? So other things, lot of ways. Job lib imported. Now what I want is I want to output first logistic pipeline.pickle. I have the pipeline here. I'm going to save it. All the pipelines are saved here. See this. Now I'm using .pkl as format. So guys, using job lib, you can also, this is one of the assignment I gave, but you can save the pickle file from here. Yes or no? Extension is not job lib extension. This time is pickle. Clear? Or from the pipeline, if you want to understand the coefficient, guys, in the linear regression, if you check the model, where was our model? Give me a second. In the linear regression, our model was at linear regression, the object. We were checking the coefficient. Here in the pipeline, can we directly use coefficient? Can I use something like coefficients? In my pipeline, I have two things, preprocessor plus the CLF model. Will it work? It will not work. But in the pipeline, as I mentioned, pipeline is, if you print this pipeline, let's see. If you print this pipeline, you will see some awesome thing. This is a good visualization. Yes, you will see you have simple imputer, you have standard scalar, and you have this logic. But you all of this logic is going into logistic regression. Yes, this is your logistic regression. And your logistic regression, just wait, okay? Yes. What are the different elements of this pipeline? Preprocessor and CLF. So if I use pipeline in bracket of CLF, and CLF is our trained model, yes or no? CLF is our trained model, yes or no? We already done the fitting. If I print the coefficient, are we able to get the coefficient? Yes. Okay. So that's how we do it. So my point of showing all of this is you as an engineer should be able to do everything. Don't be scared of anything. This notes will serve you as like a challenge, but if you are able to understand everything and try to practice it, you will not face any issue. Guys, trust me, agentic, LLMs and others will, once you understand the whole machine learning and the way I'm teaching all of this, everything will look very simple to all of you. Guys, where is the beta? Where is the better term? Where is the better term? Intercept. You guys are not remembering. Guys, these coefficients are already updated. We fit the model. Yes or no? We already done the fitting of model, guys. Why will it update? We already done the fitting of the model. Where we are. Say this. When we mentioned pipeline.fit, that is sklearn and processor, first the fit will go to the preprocessor and done the fitting and transform on the data. Once this part is done, then it will jump to the next task. The next task of this pipeline is the model itself. So this fit is doing fit transform on the data using processor, and then fit on the CLF using Xtrain. So we have done everything here. And I've shown you, if you don't want to use pipeline, use this. But my recommendation is to practice pipeline, not always implement pipeline, but to practice pipeline. So our model is done. This is our intercept term. If you don't want this array, then you can also use NumPy. Guys, this array is in 2D. What function of NumPy we should use to remove the additional dimension? This is all the variables are present inside a 2D list. It's not even a 2D. Guys, not in a list. I want to reduce one of the dimension. Here it is 2D. What should I use to remove the dimension? If you guys remember, I have shown you, correct. Reshape you can also use, but if you just use flatten, it will just remove the one of the outer dimension. We have not passed learning rate. Can we pass? You can pass learning rate. Okay. Logistic regression has a lot of components, guys. You can check later. Where is that? I wanted to show you this logistic regression code as well, but okay. Maybe if we have time. See, go to definition. It is not loading in my system properly. But you guys can click on it, go to definition, and you will see all different kinds of it. Okay. Do you guys want to see the actual code of it? How many of you want to see this? You, me, everyone? Okay. Let me stop sharing for a second and let me show you that as well in your system, how it looks like. I just want to check where my Anaconda is installed. Users. Just wait, guys. Okay. Give me a second. Okay. Let me share the screen. Guys, because I'm showing, don't say that, sir, you are wasting our time. Okay. Everything is a part of learning. So here we have our packages. This is my Anaconda main directory. Okay. Miniconda. Environment. Okay. Currently, we have a lot of different environments, right? I have a lot of environments. What I want to see is my base environment. Let's see. Library, bin, not the library. SQLite, CMake. Okay. Let's search for sklearn if it is present here directly. Okay. sklearn. Are we able to see sklearn? Side packages. In sklearn, what is the model which we are using? Linear model. Let's see. Okay. We are using logistic. Let's look for the logistic, guys, if you're able to see any of it. Otherwise, I will look in the linear. Maybe it is present in the linear. Let's look. And logistic. Yes. Let's open it with VS Code. Don't change any code. If you change a single code, your Python library will not work. See this. Check solver. There are a lot of things. But we are interested in capital logistic. How many of them we have it here? I just want to check the exact function name which we have used. Okay. We were using logistic regression capital. So let's look for logistic regression. Are we able to see logistic regression CV? It's another class, but we also have another logistic regression. Let's check. Is this the class we were using? Everyone say this, but you will not be able to read a lot of things because everything is very optimized, but you will understand. See this, we have penalty L1 and L2. Do we know L1 and L2? Do we know L1 and L2? Yes. There is something called as dual. You guys can check it, but there are a lot of arguments which we have. Class weight, diet or imbalance, or imbalance, that is a different thing. Random state we also use. We are using solver of liblinear. Yes, you can see all of this information. Don't change a single thing. Maximum iteration, multiple class, verbose, and jobs L1 ratio, coefficient F are the attributes of this particular class. So you can check whatever class supports. Guys, verbose I will talk about. Verbose is nothing but whether you want to see all the print statement or not. Otherwise, it will fill everything whenever it is training. Okay, we'll talk about verbose later. So this is how you can check it. All the libraries are nothing but your Python function. Clear? We can get this from sklearn.library. Yes. But always, guys, make sure sometimes in the deployment, you have to go inside the library and suits and change something if it is not working. Maybe you are using some different version. So sometimes understanding that libraries are really present in your environment. Okay. Pankaj, why are you always waiting for class to be finished? How many of you are waiting for class to be finished, guys? Guys, if class is finished, your learning is also finished for today. Always understand that. Okay, done. So, feeling exhausted? Okay, I will tell you. Everyone, now, do you want me to teach a new topic or you everyone is done for today? Everyone tell me, are you done for today? Tomorrow? Done? Defeated? Done for today? No, let's do tomorrow, done for today. Okay. So guys, tomorrow only few things are left. I will cover tomorrow support vector machine and I'm not sure how much of it we are able to complete. Let me let me show you. Everyone is tired. Don't worry, guys. This is why it is not loading. Okay. Don't worry, guys. I will not pitch if you guys are overwhelmed. But introduce new topic. New topic means new concept. Now it is not okay. Everyone, we have completed almost till this part. I will talk about AUC curve, ROC curve, that is last part of logistic regression. We have covered all of this. Plus, I'm giving you small information which is not even a part of the syllabus. Then we will go to SVM, and I think in this week we'll not sure able to complete all the SVM, but we'll be able to complete this big part. Next is once we are familiar with all of that, then we are going to KNN is very simple algorithm. Decision tree is going to take little time, but ensemble methods and others are also very, very, very simple to understand. Okay. I think support vector machine is repeated 2 times, so I will delete. This is not even required. Okay. Something is shuffled. This is the start of unsupervised. Then we will start with Bayes theorem and other parts. Okay. So I think we'll be able to complete it and 5 6 classes. A lot of the things we'll be able to complete in 5 6 classes, majority of the machine learning. Okay. Yes. All right, guys, we are done for today. I am raising a poll, so I hope everyone enjoyed today's class. Even if it is overwhelmed, we are able to learn something. Yes or no, guys? Yes or no? Yes, amazing class. So guys, do you want me to follow this pattern of teaching the whole concept of 2 3 algorithms, then showing the practical, or you like this one better? Concept, practical, concept, practical. Tell me. Concept and practical. Concept, practical. Okay. Okay. CV is a part of course, but not in depth. Guys, every specialization cannot be in depth, but machine learning is the core part. That's why I am focusing on it too much. Please send the file. Yes. Let me create a zip in the meantime. Okay. Thanks for reminding. Just give me a second, guys. I'm doing everything. Let me delete linear regression. Linear regression. pickle file is also your data set. Okay. Everyone, the assignment I'm giving is the same assignment of the previous class, that is to create a PY file. Are we clear? To create a PY file which can be act as a product, I will pass as an input and I should get a classification whether that person is having diabetes or not. It should not say 0 or 1. It should say you have diabetes with this much percentage with this probability. Are we clear? You have a chance of diabetes with this much probability. That should be the output of that script file. Are we clear? Yes, guys, please do make it. I've given 2 assignments and it will really help you. Only then, only when if you create it. 1110 data set. Okay. Let me double check everything before zipping. Okay. And again, any one of you guys can please put the same zip which I'm sending to everyone on the community so that people who don't have access to it will be able to see it. And if you are done with that, please let me know. Okay. And whoever has doubt, please raise the hand. Although there was no concept in today's class, but still, if you have something, let me know. Mohan, sir, will you also teach deep learning in depth? Only if you guys want me. Whatever I teach, I will always teach in depth. See, guys, if I don't teach something in depth, I personally feel like I'm wasting my time. Not sure, but I don't want to waste anyone's time just skimming through topics. So, okay. Yes, Mohan?
Uh, so my doubt is that I just want to know the which settings or the plugin you are using, the way your Python code get highlighted, it is different. I am trying to do
Ah,
that, but
it is a
I'm not
theme.
able to achieve it.
It's a theme, Mohan. Okay. It's a
So
theme.
which
You
theme
can use
exactly
any
you are
theme.
using?
See, I will show you. There are a lot of different themes, but I personally, I keep on changing. I think few months back I was using a different theme. Now I'm using a different theme in the same class. Okay. So, do you know how to apply for theme?
I where I just like a themes.
Oh,
Okay, VS Code and then
in extension, just search for theme. Okay. And
okay.
use whatever theme you want. There are a lot of themes. Whatever you is up to your liking. Sometimes maybe in your system, my theme will look very weird. So based on your display configuration, just apply the theme which looks good to you. Just download it and apply it. That's all.
There is nothing specific to Python. I don't see. Lot of themes
No,
are there. Studio
there is
1.
not specific to Python. Just use any. Check 10 of them and it is good. Every theme has a different color configuration.
Mm-hmm.
And also, are you not able to see any color at all in Python?
I am
Any
able
color.
to see, but mine is totally Python TGM theme. I'm trying.
Do you want to show the screen?
Python themes I got, 90K likes, 2690K
Okay, okay.
default.
Can you please share your screen? Others can also see that if you they got. Okay.
Oh,
Can you please join as attend? Can you please join as a panelist? Everyone, if you guys want to uh, check the theme, theme makes us like the code better, so you guys can check it. Mohan. All right, guys. I'm ending the poll because I think people are not answering anything now. Yeah. Okay. Just thank you for. Okay, I think one there is some issue, but I will show you guys. Everyone, see this if you want to see the theme. Mohan, don't worry. Everyone look at the screen. This is my VS Code. You just have to search for theme here. Okay. And you will see hundreds of theme. One is very famous. One is Dracula. You can still use One Dark, Synthwave, Jellyfish, whatever you like. You just need to click on it and then do the installation. You will get to see this themes applies to any programming language. Still, if you
Okay.
don't get to see anything, just write Python here and make sure that in your VS Code, Python is installed. Let's see. I'm not sure whether Python is installed in my system, but yes, see. Are you able to see Python? So install Python. So everything, debugger and other things are also accessible in your VS Code. Are we clear?
Oh, oh, hello.
Hello? Yes, Mohan.
Yeah, actually, I got disconnected
It's
somehow.
fine. It's fine.
I
But
don't
you're
know.
able to understand, right? Install
And
Python from the VS
I
Code
missed
and choose
everything,
any
whatever
theme
you
you
tell.
like.
Sorry about that. Can you hear me?
I can hear you, but I think there is some lag.
Oh, there is lag.
No, no,
Okay,
it's fine.
there
It's
is.
fine. No, it's fine. It's fine now. Yes.
Okay, can I share my screen? Okay.
You can share, but it will be the same thing. Let me check. Yes, please share
Okay.
it.
Oh, because sorry to
No, no,
tell
it's
you,
fine.
but actually somehow it happens in my system. It was showing connecting. I missed everything that whatever you are talking. The moment
No,
you
it's
asked me
fine.
to share my
Okay.
screen.
Okay.
So can you
So
see my
just go
screen
ahead.
now?
Yes, see, it is working, but I think the Python part
No,
is not installed.
I didn't do anything. That is how it looks like, and it is not same as the yours screen. And
Yes,
see,
I know. Can you click on extension?
it is it is a blue.
Yes, yes. Can you
Okay,
click on extension? It is getting
okay.
recognized. No, no, not here. Yes, it will work. Click on the extension. Search for theme. Any theme. THEME. Just search for theme. Sir, now apply the Dracula, the sixth one. Below atom, there is one called Dracula. Yes,
Dracula
click on
official
it.
thing,
Yes, yes,
9.5 million, right? This one.
yes, yes. Click on it.
Okay. Test.
Yes. Install. And also in the meantime, instead of theme, yes, apply the Dracula theme, the first one.
Mm.
Now, instead of theme, can you please search Python? Then someone is there on your door.
No, inside the themes, which
Yes,
side?
no. Where you're searching the extension, you have written theme, right? In the extension, you are searching theme. Now write
Mhm.
Python.
P by THU and Python, right?
Yes. The second one, you will see the not the below PyLint, there is something called as Python. Below PyLint. Below PyLint. Yes. Click on
This
that.
one.
Yes.
Why Microsoft, right?
No. Yes. Click on it. It is already there.
Mm-hmm.
Okay. So I would suggest you to restart your VS Code and then see if it is working or not. Otherwise, there is some issue that it is not getting. It is able to understand Python. Now, can you click on something?
And Python, it
Animate
is able
Python.
to. Oh, now it's different,
See,
right?
it's
That's
working.
true.
But
It
you
is
are getting
working.
that underline. Maybe check some VS Code why it is getting all of this weird thing. Okay.
Okay,
See,
so but at the
can
end line,
you scroll over it? Can you scroll over DEF? Just hover over DEF. Just hover over DEF. Let's see what is the error. See, it is giving you PyLint issue or something, but it is not the problem. Your VS Code is sometimes behaving.
I think the issue maybe with my
Indentation is
virtual
correct or
environment
something?
because
No.
yeah, this code is formatted only missing doc.
But the color is coming now, right? You're able to see
Yeah, now
colors.
I can see. I now can see
Okay.
very different color. That's what I
Okay.
understood. Like I need to
It's just
apply
a
the
theme.
theme.
Okay. You can use. There are hundreds of theme which you can use. All right.
Okay, which one I like, I can install. And
Yes.
okay,
Yes.
and one more thing. Actually,
Mhm.
there's a it's another question, but I just want to ask you. Hey,
It's
stop.
fine. It's fine. It's fine. It's fine. It's fine.
Okay,
Yes.
so actually, this is my project code, and I generally use PyCharm, but somehow I cannot use it. But what I wanted, just like when I call, just like this piece of code, okay, and there I pass a lot of argument. Those
Are
argument
you
I'm
supposed to share all of this, or do you want me to pause the recording?
uh, okay. You can pause the recording.
Recording stopped.
Okay.
Okay,
Always
so
make sure that you have this. Okay.
yeah, sorry to
Yes.
that.
Yes.
Okay, so this piece of code is there. So what I want, like that these argument in some other language I can pass as a
Yes.
argument, like if you see this one, okay, you go here, and for this project suppose I am doing it like this one, okay, I can pass this as a script parameter, and it is provided because they are the paid software. But VS Code, there is no such option. So because you
VS
guys
Code
work.
is not made for like VS Code is not advanced like PyCharm. PyCharm is very advanced. VS Code is just like, as I told you, right? It's a little hybrid of your editor plus little bit of IDE. It's not a fully ID. Okay. But in the extension, maybe you will be able to find something like how to test py file with arguments. Maybe check on
Mhm.
internet in the one of the you might find in one of the extension, but it is not a comprehensive software like PyCharm. Okay. PyCharm is
Mm-mm.
made for everything. Just like in Java, we have Eclipse, but VS Code is not made for that. Okay.
Yeah, right, right. So these
Yes.
arguments. So just want to know that how you purchase.
Yes,
So
Alok.
I was exploring different options. They told in the .bs code.
Maybe check in the extension. You might find something in the extension because there is extension to a lot of things. So maybe
So
try on
they can
internet, ask
try to
Gemini
pass
or
it here.
AI mode.
Task.
Yes, yes.
Mhm.
Ask Gemini or someone that how should I pass the argument? Maybe you will find some widget or you will find some extension which can do that in VS Code as well. Okay.
O- Okay, I find this option launch and task that you can do it, but just want to know if you guys if you
Hmm.
using more, then you
Yes.
may be having the quick answer
Yes,
for
yes,
that.
yes.
I
The
was just
similar
doing
you're looking
sometime.
might not be find here, but workaround you can find here. Yes.
Okay,
Okay.
yeah, okay, good, good. I'm good, fine. Thank you.
Sure, sure.
Thank you for teaching all these wonderful stuff, and I really
Thank you
appreciate
very
it.
much.
Okay.
Thank you very much. I think you already know Python, right, Mohan? You're doing a
I
lot
know
of
Python, and I
projects.
don't know the
That's great.
Python. I started around 1.5 year ago. Little bit I know, but the
Wow.
way the concept you are teaching, that is really different and good. And I just trying to apply whatever you're teaching in my real project, so that
That's
I can.
that is awesome. That is awesome. Mohan.
Thank you. And only thing
Sure.
that the machine learning I want to, but just not thinking that is not my job. Not I don't needed it, but the way you are
Mhm.
teaching the concept, they are so overwhelming. I say they're so nice. Okay, so
Okay,
just
that
trying
is good.
to.
You are able to understand it and you are able to apply in your job. So that is good. Yeah.
Thank you.
Sure, Mohan. Yes, you're welcome, Mohan. All right. So next one is Jonas. Jonas, are you there?
Hello,
Hello. Yes,
how are you? I think
I'm doing good.
today's
Yes.
your lesson is like a little bit. It's good even if like you are teaching up for a production level, so you are uplifting to junior level. So I'm happy. So
Thank you.
I have
Yes.
question with
Yes.
some kind may I share my screen?
Yes, you can share your screen. I promoted it to panelist. Please join as panelist.
Okay.
Yes, correct again, IntelliJ, Java. But I think we can also use Python in IntelliJ,
Academy
right?
for
KK?
me.
I'm not sure. Yes, Jonas?
Okay, let me share. I take some. I think is that visible? Am I right?
Yes, yes, yes.
So I take some courses like before 2 months, 3 months ago, like ML Lab. So
Ah,
I do ML Lab flow. So like today's class is logistic regression. So
hmm,
I got some problem for logistic regression. I think this is the right place to ask you. So this one, like this is like from Krishna Academy, from Krish, and after linear and logistic regressions. So like he's scoring, let me accuracy. Yeah, he makes the accuracy 0.9.
hmm.
But we are the same course, but I do like some the same things, but my accuracy like one means like 100%. Like, is that acceptable?
One, yes, it is acceptable. And we need to test what is the accuracy of training versus testing. If both of them are one, because the data set might be too simple to understand, then that's why we are getting one. It is acceptable, totally acceptable.
So even if I'm using like a different parameter, like today's we are the last
Yes.
question we're talking, we are little parameters. Even if I'm using some parameters, some stuff,
Hmm.
uh, I got like one, so I have no reason just at that time. So that's what I'm asking you.
It is totally fine. Getting one is totally fine. It is very rare in terms of when the dataset is complex. When the dataset is very simple, then it is very easy to get a 100% accuracy in both
Even
training and
if like
testing.
I'm changing like with a different iteration, multi-class, some random, so I'm using new intensity. The same
Yeah.
thing is it happened one, so I cannot get answer for other times. Okay, it's no problem.
Hmm.
Like even like a simple
It's not
data
a
set.
problem. It's not a problem. Yes. See, there is another way to test, which I will teach in the next class, that is cross validation. Okay. If you really
Okay,
want to understand your model and don't want to depend on a single test set, you should use cross validation. Okay. Which I will teach
okay,
tomorrow. That will help you
okay.
test model better, not just a general sense of getting 100% accuracy in a single test set. There we will have multiple test set. Okay.
Okay, got you. Okay, thank you.
Yes. So that is a better way to implement it if you always get a one, or just a better way to train the model. Okay. Sure.
Okay,
Yes. We'll show you tomorrow.
okay.
Okay. Thank you very much, Jonas. Good work. So final one is Deepak. Deepak, you're next. As Deepak is the final one, then we will wrap this class. Okay. Hello, Deepak. Deepak, are you there? Lalit, can we hide password in an environment variable? Lalit, environment variable is also accessible via Python. Why will you want to hide
Yeah,
it? Yes, Deepak.
yeah, thanks, Monal. My question is
Mm-hmm.
related to gradient descent. So just
Mm-hmm.
wanted to understand there you are means we are trying to find M1, M2, M3 something you give the
Yes.
yeah, okay. So in that for getting those number we you running the loop like thousand of the times, right?
Yes.
I want
Yes.
to understand, is there any concept kind of things ki how many times we have to run the loop kind of.
No, 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 no. No, no, no. See, loop is not a concept which we run. What we do in real world, I will tell you. In
Mm-hmm,
real world, we set the loop when we are going into deep learning, just like ChatGPT, right? If
mm-hmm,
you ask in terms of ChatGPT, we cannot train a model in 100 epochs and then let's say we get accuracy of 20%. Then
mm,
again, we have to do more 100, right?
correct.
So we cannot have that cost. We cannot just train, keeps on training 1,000 times. So what we do in deep learning, in computer vision specifically, you will see that you can set a epochs to whatever the maximum number you want. Let's suppose you want to set it for 1 million epochs.
Mm,
Okay.
okay.
Once you reach to a specific condition, once you can in the Python, can you write a program that if your previous 5 losses is same as the current loss, then I will break the loop. Can we do
Yeah,
that?
yeah.
So that's how we stop it. So it is intelligent
Okay.
way to stop it. We can set to any maximum value, but let's suppose in the 5 losses, we are now at the 90,000 epoch. But in of the previous 5 epochs, our loss is decreasing. Our loss is decreasing, but by a very, very, very minimum value. You can
Mm-hmm,
choose it. You can create a factor that if the previous few values is 20%, or if changing 20%, or whatever you want to do,
mm-hmm,
whatever you want to stop condition, then you can stop it, or you can keep on going it. So that's how we control it. So there is no hard and fast rule that 1,000 is the goal. The goal
mm-hmm,
is whatever, because we don't know the features, right? Every data
correct.
set is simple. Even if you change the random state from 42 to 1, then
Mm,
the loss will go in a different way because the data is different now.
okay.
Are you
So
getting a point?
yeah, yeah,
Yes.
yeah.
Yes.
So okay. So there is no any kind of rules like you know.
There should not be.
Yeah,
Okay. Mathematically speaking, there should not be, because loss is something which is being calculated every time, and we don't. How can we know that in a single go that we will reach to that point?
correct.
Right?
Correct. So just one
Yes.
question. Let's
Yes.
suppose 1,000 time we are running it and we are not getting that perfect value of M1, M2, M3 that we are trying to achieve. So
Hmm.
again, just one question. Next time might be we are running 1,500 times and then trying to get it kind of things. M1,
We
M2,
can
M3.
try. See, what we need to do is
Uh,
within those 1,000, I was printing loss for each and every epoch, right?
hmm.
First, when you run for, let's suppose, 100 epochs, okay,
Okay.
you will check if your model performance is either, let's suppose, your training accuracy is 50% or your loss is 160.
Mm-hmm.
Okay. You will check the previous 5 because you are printing everything. You will check from the previous 10 epochs, 20 epochs. If the loss is near to that 160 itself,
Okay.
if the loss is near to 160 means we are not able to learn.
Okay.
You're getting a point?
Yeah. Yeah. Yeah.
And when we are not, if I tell you to, I'm giving you two numbers, 2
Mm-hmm.
comma 10. Okay.
Mm-hmm.
You
Mm-hmm.
have to reach till 20. Which
Mm-hmm.
of the operator you will use? I'm giving you 2 comma 10. You have to reach till 20. Which of the operator you will use in mathematics? Single operator you have to use to reach to 20. What you will do? Will you use multiplication, addition, division? What you will use?
Multiplication to
2
10. Yeah.
multiplied by 10 will give you 20, right?
20. Yeah.
So what was that? You can do that with positive, but you might not reach there. Yes,
Correct.
you can use positive. It's not like you cannot use that operator. You can use positive. You will get only till 2 plus 10, that is 12. You
Mm-hmm.
are near to 20. Yes or no?
Correct.
but you are not there. So if an algorithm is not able to solve, you have tried everything, it means that algorithm might not have the correct mathematical intuition to reach towards that loss, to reach towards that minimum loss.
Yeah.
That's why there are a lot of different algorithms that try to solve. Currently, I have not told about the concept of local minima, global minima. That
Mm-hmm.
loss that we have, that
Mm-hmm.
loss sometimes is local. That's why we are stuck in that loss and it is not going down. There's some other algorithms, some other activation function which help you reach towards the final loss. So there are a lot
Okay.
of concepts which are coming. Okay.
Okay. Okay. Thanks, Manal. Thank you
Yes.
so
Yeah.
much.
You're
Yeah.
Deepak. Yes.
Yeah.
You're
Great.
welcome. All right. So guys, we are done for today. And thank you very much, guys, for joining. Tomorrow will be the last class for this weekend, and the next weekend is again holiday. Okay, 2 days is holiday. So keep this in mind. But uh, come fresh to the class because we have to cover a lot of things, and that's all. Okay. Thank you, guys. Good night. Have a nice day. Bye. Bye, guys.